It's the proton smasher.
Proton smasher. Yeah.
Right, so we're going to...
So that picture is the actual size of the collider, but it can't fit the whole collider in the picture.
Yeah.
So it's only showing a small fraction of the entire machine.
Over there. It's a great place. Look at those mountains.
You know what that area of the tube, not of the collider itself, but the tube, that big.
And that's Square Galileo Galilei. And we're going inside now. It's a great model. Yeah. Accelerating science. CERN. Oh, look at this place. Oh. This is just a place for information, like you can explore, click on, whoa, come on, stop moving. Big Bang, and if you want you can click on like, what ice melts? I know when ice melts. Who doesn't know that? Of course at 0 degrees Celsius. Okay. Alright, see you Kelvin. Oh yeah, the lowest temperature that's been reached is, oh man, that's low. I bet you can't reach 0. That's the closest. Now, it's here, just information. We can't go down to the, you know, where everything happens. There are too many people there. We can't get a guide. But this is good enough. What's this? Oh. Whoa. I don't even... What do you see?
Antimatter.
Okay. Crystal detectors. Really? That's cool. How detectors work. Well, it's a pretty cool place. What? Oh, really?
The first web ever in 1989.
Cool.
Invented the World Wide Web.
Server.
First internet.
Is it this box?
Yes.
Oh.
The first server.
Here at CERN? Cool.
1989. You haven't been born?
I wasn't born. Okay.
This is the first surgery.
The first website in the world.
Yes.
I didn't know it was here at CERN.
It says it right here. Science Without Borders, the first World Wide Web server.
Cool.
And when I talked to them, the physicist I spoke with on the interview told me that they didn't do it because they thought they were inventing the World Wide Web. They did it because they had so many different people who needed to get information and be able to access data files that they asked some of their technicians to try to find a way to make some sense of all of it and help to traffic those different pieces of information. And what they came up with turned out to be the internet.
That's
and they shared it with everybody for free because they thought that that was a good service to humanity, which I think is a fantastic story.
Who's talking? What's going on?
What is it made of?
So random.
How did it start? For thousands of years, mankind has been wondering about these questions. The LHC brings us closer to an answer. Everything started at the moment of the Big Bang, 13.7 billion years ago.
Oh man.
Time and space begin when a tiny point full of energy starts expanding at an incredible rate.
Who started this?
An unimaginable amount of energy transforms into matter and antimatter. But shortly after, all antimatter has disappeared and only a tiny fraction of matter is left. Still enough for all the stars and planets in our universe. In the first 3 minutes, protons and neutrons form the lightest nuclei, while the universe continues to expand and to cool down.
Oh man.
But it takes almost 400,000 years until hydrogen and helium atoms can form. Now the universe has become transparent. Light from this era can still be seen today as the cosmic background radiation. Gravity begins to pull the hydrogen and helium together. Stars are born. Fusion inside the stars forms heavy nuclei, the base of life. And these building blocks are thrown into space and stars die in giant explosions. After 9 billion years, gravity pulls some of these remnants together to form our solar system with our planet Earth, where evolution gives rise to life, intelligence, and consciousness.
Earth. The Earth is here.
Since its awakening, humankind has wondered about its origin, and today we have developed the tools to give answers. Scientists from more than 100 nations are working at CERN on the Large Hadron Collider, the most powerful tool to study the first moments of the universe. The LHC is a circular machine of 27 kilometers circumference that accelerates billions of protons to more than 99.99% of the speed of light and collides them in 4 interaction points.
Alright, this is cool.
4 huge detectors take snapshots of each collision up to 600 million per second. In these collisions, energy is transformed into particles, just like in the first fraction of a second after the Big Bang. big questions. Will we find the reason why antimatter and matter did not destroy each other completely? Will we understand the primordial state of matter before protons and neutrons formed?
I want to try one of those chairs. They seem comfy. Oh well. That was pretty cool. That was very cool.
Why do particles have a mass?
I got in.
First thing in the morning, I sometimes stand on the stairs and wonder why I weigh more than I did last week. Well, one thing is sure, it's not the force of gravity that's changed. I probably ate too much. But why do I weigh anything at all?
It's comfy.
That sounds like a stupid question. But actually, it's a clue to a deep mystery
Yeah.
of physics. From Newton, we know that masses attract each other. My body is made of particles, so it is the mass of these particles pulled by the mass of the Earth.
I'm getting shirts. This is for me, and this is for my brother. It's cool. You'll like it, I hope. You better like it. And I'll get a pen. I hope I'll get that pen. I like that pen. Where's the pen? There's the pen. That one. I want the blue one. CERN. This is the shirt. T-shirt. Pen was out of stock. Aiden, you better get that pen for me. Should be in stock when you're gonna get there. Oh, the shirts? Yeah, they're cool.